Let's talk about parallel lines and perpendicular lines. Whenever we're talking about a parallel line, we're talking about lines that run beside each other. So, for example, you can have them running at an angle, right? The interstate, right? When you get on the interstate, the lines are parallel. So you have the leaving and coming lanes, and they're parallel to each other. So it doesn't matter about the angle. So I could draw them on this graph here. They're going to be parallel. One thing about them is they're inconsistent. Why are they inconsistent? Because they do not share any order pairs. So this XY value could be right here. 0 for this, let's call this order pair right here. 0 for X, -1 for Y. This other line does not have the same order pair. So it's inconsistent, okay? But there is something they do share in common. Since they are running parallel to each other, they're running at the same slope. So let's call this line L1 and this line L2. And this tells me, since they're running at the same angle, that their slopes are equal. So my slope 1 from line 1 is equal to my slope 2, line 2. So let's put this into action. I have a application problem here that says write the slope-intercept equation for a line passing through these points. So what I'm going to do is, before I read the whole thing out, I'm going to go ahead and write this up where I have a column for line 1. And I can write it just a little bit neater. It helps. Column for line 1, L subscript 1. And in that column, I'm going to have this order pair of -3, 1. And then over here, I'm going to have this line subscript 2. And let's finish reading it out. It says that these two lines are parallel to each other. Oh, wow. Okay, so let's come back, and in the middle right here, let's write my slope from line 1 is equal to my slope from line 2. Now, let's finish reading this out. It says my line 2 is going to be y is equal to 2/3 x plus 5. All right. Well, what I notice about this equation for line 2, it's already written in slope-intercept form, so I don't have to do any extra solving, which is always good, right? Well, I know what my slope is here. So my slope for line 2, because it's already written in my y equals mx plus b format, right? Yay, we love that. We know what our slope 2 is, and it's 2/3. Please do not put x with it, because x is not the slope, guys. Some people accidentally carry it over just because they're writing what you see. So if this is true and they're both parallel, then that means my slope 1 is going to be 2/3 as well. So now I need to do some work, and I need to solve for what is the line that is parallel to this other line. What is the line for line 1 that's parallel to line 2? So I like to use this one method. If you want to use the point slope formula, you are more than welcome to. If you haven't heard of it, that I have created a video over it that's uploaded as well. But I want to do this because I know that I have my y value, my x value, and my m. All I need is my b, and then I can turn around and say, okay, my line 1 is going to be y is equal to 2/3 x, and then I just got to find b in order to finish this line out, right? So let's do this. Let's put parentheses everywhere's needed plus b. Now let's plug in. My y value is 1, my slope is 2/3, and my x is -3. So now let's solve. Well, if it will help you, put a 1 underneath this whole number because it seemed to be over 1, and you'll notice that 3's will reduce. 3 goes into itself once and goes into this self once. So now I have 2 times negative 1. So I'm just going to rewrite it so you can see it better. Now let's solve for b. In order to solve for b, I need to get b by itself, and this negative 1 needs to move. So I got to make it go to 0 by adding 1. So I add 1 to this other side. Now I know that b is 1 plus 1, which is 2, and it's a positive. So here is my my parallel line of 1 to the parallel of line 2. And that would be my answer. And of course now I can graph both lines and I can see how they run beside each other. So now let's talk about perpendicular. Perpendicular is a set of lines that intersect. So like when you come up to a four-way stop, that's a perpendicular because you're intersecting. You may be going north and the person going south to north, and the person to your right is going east to west, so, or west to east, however you want to read it. But the point is that whenever we talk about perpendicular lines, we are talking about a line that has a 90-degree angle between them. So we have this line here. Whoops, terrible drawing. Let's fix that. We have this line here that intersects with another line. And they could be more at a slant as long as they have a 90-degree angle. If they don't have to run like this. I'm just trying to give you an example. This is a consistent set of lines. Why is it consistent? Because where they intersect at, they both share that same order pair. Okay? But what else I know is that I got line 1 and line 2 is that since they are running different directions from each other, they do have a 90-degree angle. This tells me the slope of line 1 is the opposite, right? So if the slope of line 1 is positive, then the slope of line 2 would be negative, vice versa. And it's a reciprocal number. So we'd flip it, whatever the other is, vice versa. So if I had, just for example, I had a negative 2 for line 1, then my slope for line 2, right, this is line 1, my slope for line 2 would be a positive because the 1 was negative, and then I would write its reciprocal. It was a whole number, so I'd flip it to a fraction. It could have been already a fraction, and we're just going to flip it. And since it's positive here, we got to add on the negatives. So, reciprocal and opposite. Okay, it's perpendicular. So let's solve this equation here. So I like to read it in parts. I know that I got line 1 that passes through this order pair, so I'm going to go ahead and write L1, and I'm going to go ahead and write the order pair of negative 3, 1. And then I'm going to finish reading. It says it's perpendicular, so if it's perpendicular, then I know that my slopes are going to be opposite signs and reciprocal numbers. So that's my perpendicular. And it said line 2 is y is equal to 2/3 x plus 5, and yay, because it's already written in the slope-intercept form, it saved us all this extra work. So that's always a good thing. And we know now what the slope is because it's written in slope-intercept form. And if they're perpendicular, then that means, since this is a positive, right, so let's write it down, slope 2 is a positive 2/3, then that means slope 1 is going to be a negative 3/2. So now I have everything I need to solve for line 1. And I want to solve for using this method here, solving for my y-intercept. If I do that, then I can come over here and already write part of my answer is y is equal to negative 3 halves x. Now I just need to figure out what b is. So what I'm going to do is I'm going to plug in everything I know. Okay, so I know that y is 1. My slope is a negative 3 halves. And my x is negative 3. So when I go to solve this, if it would help you, you could put a 1 underneath this negative 3, so that way you can see that it, you multiply straight across and you reduce. Well, 2 and 3 doesn't reduce, so I need to multiply straight across. So I got 1 is equal to, this negative times negative is a positive, 3 times 3 is a 9. Alright, so we're almost done. I need b by itself. I need it to have a positive 1 coefficient, and I got this 9 halves been added to it. So that means I need to subtract the 9 halves from both sides. So when I do that, now I got 1 minus 9 halves. I'm going to do some extra steps here because I want you to refresh your memory on basic math. This seems to be a struggle sometimes. But whenever you add or subtract fractions, you have to have a common denominator. And if it would help you, I'm going to rewrite it just one more time. I'm going to say 1 over 1, because that's what 1 represents, right? And I'm going to say minus this 9 halves. Well, I see that I got 1 in the denominator and I got 2 in the denominator. And we got to pick at least common denominator that they both will go into. Maybe not the same amount of times, but they will both go into. I see 2 will go into 2 and 1 will go into 2. So that means I need to multiply this 1 by 2. And what I do to the bottom, I have to do to the top. So when I do that, now I got 2 over 2 minus 9 halves. And since the denominators are the same, I can go ahead and do another step and come over and write everything over that 2. So 2 minus 9 is 7, and it's not just regular 7, it's 2 minus 9, so it's a negative 7 halves. So now I know what my b is. It's a negative 7 halves. And from this, I can graph my perpendicular line 1 to perpendicular line 2. And that's how you solve. Thank you.